Heap overflows are problematic in that they are not necessarily protected by CPUs capable of using non-executable stacks. A heap is an area of memory allocated by the application at runtime to store data. So we're going to use our example program again. Define buffer size as 16 and oversize as 8. Create two buffers, buff0 and buff1, with memory allocation with a buffer size 16. The heap is used for dynamic allocation of variable size blocks of memory. On successful execution, malloc returns a pointer to the newly allocated block of memory. Calculate the difference of two buffers and print the initial values. Now here, memset sets the first 15 bytes of the array buff1 to the character h. Here, memset sets the size is typecast with int, containing a total of 16 bytes plus 8. That's 24 bytes. Now remember that the size of bug0 is 16 bytes, whereas I am trying to set the first 24 bytes of buff0, so it will go into the first 8 bytes of buff1. Buff already has h written in, so when I execute this, it should write in buff0 and into the first 7 bytes of buff1. A lot of math here, right? It should have prevented it from writing, but it looks like it didn't. This is what we call heap overflow. Now, compile the program again and run it and see the output. The initial value, our buff0 is 0 times 1 A69010, and buff1 is 0 times 1 A69030. The difference between the two buffers is hexa 20 or 32 bytes. Now, before overflow, the buff1 variable shows 15 times, again, h. After overflow, buff0 has all t's, and buff1 shows 8 times t and 7 times h. This is how heap overflow can be initiated.